Okay, so as promised, today we are going to get to look at some really pretty graphs um, because graphs in polar form make some pretty interesting shapes. If you look at the back of the notes that I had given you, um, you can see it's just a page from the book, so you can look at it in your book as well. But on there, it shows you kind of the formats for what the equation looks like and what the type of graph should be. So you can see on there at the top when you just have r equals a cosine theta or a sine theta that it's going to give you a circle. When we get the values multiplied by the theta, that's when we get the rose petal graphs. And you can see more detail about those patterns on the back. When we have polar graphs that have a value plus b sine theta or b cosine theta or minus, those give us what we call lemmasons. So it's almost circular, but with like a little dimple on the side or a loop on the side. And then the final type is when we start with r squared and we have a squared and then an n value in front of the theta. So when we square both the a and the r and we have an n value, those give you kind of the infinity symbol looking graphs, which are called lemniscates. So I thought that was a really good book page to kind of summarize, how the equation relates to the graph and all of those good things. So we are going to use our graphing calculator to graph these. So as you can see up at the top, I've got some instructions that we're going to start with in your graphing calculator. So if you don't have it, go ahead and get it out because we're going to do that. So I'm going to try to pull both over here at the same time. So we're going to go to mode and we're going to scroll down. Maybe if it'll let me. Come on. Down one more. You can do it. There we go. It was being a little fickle there. Scroll over to polar and press enter. So we are no longer graphing in function mode. We are graphing in polar mode. Then we are going to set our table as follows. So table start, you can see table set is right here. So second window, that'll get you to the table setup. So we want to set our table start at 0. And we want our delta table, that means, the interval we're using, we're going to set that to pi over 12 because here we are graphing mostly with radians. So second pi and then divided by 12. And that should do it. So then you can quit second mode. We've got it in the right mode. We've got our table set as we need it. And so then we're going to graph our equations. Now, if you look at the back of the notes, we should expect this one because we have an A and an N to give us a rose petal looking graph. So hopefully that's what we end up with if we've punched everything in right. So R equals, and then we're just going to type what we see here. So 5 sine 2. The theta is now where your x would be. So when you type x, it gives us a theta now. Close the parentheses and press graph. And there it goes. And we do end up with a rose petal, just like we expected. Now, to be able to graph that on here, that's going to be important. So we can go to the table function in order to get actual points to graph. So second graph. And remember that I had my table set to pi over 12. And so that's what this is counting by. The reason why I set it there is because if you look at these graphs, that's what we're counting by. So 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12 is pi over 2, and you can see how that continues. So that's why I set the table that way, because that's how our graph was set up. So the ones that that I had on the notes on whatever the last day was that I saw you, Friday, I guess, the 6-3 notes, they were counting by pi over 6s. So if we had fewer, breakdowns in our polar graph, then we might change our table set. But for now, we are keeping it pi over 12 because that's what we see here. So 0, 0 is our first point, so that seems easy enough to plot. So choose my color. 0, 0 is going to be right there in the middle. Then I look at the next one, and at pi over 12, I've got 2.5. So 1, 2.5. There we go. Then the next one, so next plot over, my theta is now 2 pi over 12, and I've got 4.3 for my r. So that'd be this one right here is my theta, and 4.3. So here's 1, 2, 3, 4, and about a third. So right here. Then next mark goes out to 5. So 1, 2, 3, 4, 5, right on the edge here. Having trouble getting them to plot there. And then notice it goes back in order until it gets back to 0 at pi over 2. So then it drops back to the same position here at 4.3. And then it goes at this one to 2.5. And then back to 0. So that gives me my first petal over here. Then again, if you notice, we kind of follow that same pattern as we go down, this one starting at 0, and then I had 1, 2, 3, 4, 5. And then the 6th one was back to 0 because I got to pi over 2. Now I've got the same pattern, but it's a negative radius, which really means that I'm plotting this next one first, the one over here. But notice that all the values are the same because we've got that kind of symmetry going on there. So if I go back and I scroll down, you can see, okay, well, my next value, I get a negative radius. We talked about how to plot those. So the next ones that I would really be plotting are these ones. So I go here and I go to the 2.5. And then the 4.3, the 5, 4.3 again, 2.5 again, and that gives me this petal. Then keep scrolling because I've gotten back to 0. Now suddenly I'm in angles that would be in quadrant 3, and I've got these next values here. So scrolling down, oh, I went way too far. And so then that is going to give me 2.5, 4.3, 5, 4.3, 2.5, and then back to 0. So again, you can see following that same pattern. Oops, went a little too far on there. And plotting as we go. And so now I have a beautiful rose petal. Really, again, not a lot of work for us to do because really we're just having the calculator do the work. So next one, r equals 0.15 theta. So this one is not going to be any of the shapes we discussed on the back because it doesn't have a sine or a cosine here. But again, it's interesting to see all the different types of polar graphs that we can come up with. So 0.15 theta and graph. And on this one, I need to probably adjust my table set because it stopped doing the graph here. So go back. So when our graph is stopping like that, what's happening, because remember that polar is based upon a theta and a radius. So that means that these particular values of theta that we currently have only produce a little bit of the graph that we actually want. So I'm going to go into the window here. And right now we've got the default theta min and theta max, which are from 0 up to 2 pi. So clearly that's not quite getting it done. So we can change the theta max. Obviously starting at 0 is still fine. That's where we want to be. But I'm going to move it up to 4 pi and see what happens. We may need to move it a little past that as well. We just kind of do a trial and error thing. So 4 pi, and then go back and see if that changes things. Oh, we're getting a lot more there. So we can now see like a full, rotation happening all the way around. If we were to change it again, we would continue to get more of it, but obviously this is infinite. So at some point, we really just kind of put an arrow on the end. But if you look here, if I were to change it, let's say to 6 pi and graph it again, how that little, rose looking circular pattern just continues and continues and continues. So we will put an arrow on it, but that at least gives us a really good idea of how it works. Now, because we had to go all the way up to 6 pi to really get a pretty good picture, what I'm now going to do is I'm going to change what I'm counting by, because otherwise it's just going to be plotting way too many things. So I'm going to have it count by pi over 2's, which I should have done while I was in there, but let's change the theta step and see what we can get that. Oh, then it looks really gross though if I do that. Well, we know it's circular. Let me try pi over 4 and see if that helps us at all. Pi over 4 graph. Okay, that's a lot less boxy. So that's a good kind of balance of what we need. So when I go to second table, now it's going to be, there we go. Yeah. Okay. So I scrolled in so I can see where I've got 0 here. Pi over 4 is going to give me about 0.7854 here. So this guy is pi over 4. When I look here, you can see that my radius is still really, really tiny. So I'm not really getting a lot to graph at that point. So I'm going to look, again, it was a little too boxy to see well, but at least I can see it in here. Pi over 2 is the one that's highlighted right now, so it's at about 0.23. So that's at a quarter. So I know that my radius is going to be 0.25 when I get to my pi over 2 here. So here's a radius of 1, and so 0.25 is going to be just barely past the, you know, big black center dot that's at 0. So then if I keep scrolling all the way down, you can see 3.14 there, so that's pi. So at pi, it's almost a half, so that's a good one for us to plot. So at pi, we're almost at a half there. So half. Then if we want to do 3 pi over 2, that value is the 4.7. So we're almost there. There we go. So 0.7 approximately. And then 2 pi would be the next one. So 6.28. So we're almost to 1. So you can see we're going up almost by quarter increments. Not quite, but pretty close. So we had 0.7 here, and we have almost 1 by the time we get around to 2 pi. And so then we continue that pattern. So looking at adding pi over 2 to my 2 pi is going to give me 7.85. I have to keep scrolling in here. And we've got 1.17. So we're past 1 now, and you can start to make, you know, the circular pattern here just so that you don't get your dots messed up. So right about here is where we'd be, a little past our 1. And then we go to our next increment to get to pi, the next, you know, value of pi. So 9.4. There we are. And we're at 1.4. So right over here, 1.4 gets us there. Then move to the next quadrantal, which is going to be at almost 11. So scroll down. There we are. And almost 11, 1.65 about. So 1.65 down here. So all the way around here. And then if we add the pi over 2 again to get to our 4 pi, which is the 12.566 here, we've got 1.885. So we're almost to 2. So here was 1, here's 2. And at this point, obviously this has been extremely tedious in the plotting and scrolling. So I will just put an arrow on it. And again, you can see that the pattern continues and continues along, and that's how we get our points to graph. Okay, so next one, we have 1 plus 4 cosine theta. And if you look at the format here, we see that this should give us the third graph down on what we see on the back. So 1 plus 4 cosine theta is what we're going to type in. 1 plus 4 cosine theta. And we may have to adjust the window. This one looks really, really boxy, so we probably don't want to use that high of a theta step. So we'll try it at going back to 2 pi as our max and our pi over 12, and we'll see what happens. Oh, there, it looks a lot prettier. So again, it's kind of a guess and check game with what we need to do there. So I'm going to scroll this down here. So now we can see the whole thing, and we'll go to second graph so that we can pick some points. So scrolling all the way back up to 0 here. You can see here this isn't going to be nearly as tedious because you can see the repeated values as I'm scrolling all the way up here. Slowly but surely. Hopefully it looks like it's stuck though. It's not good. I hope it stops. Not what I wanted to happen. Sometimes when I'm on the recording, this button gets stuck. And there's nothing, I don't know what makes it happen, but even though I'm not pressing it, it keeps pressing that red button. Cut it out. Ah! Okay. Well, I'm going to have to ignore that one and just press it into the calculator that I have sitting handheld in front of me because that is super annoying and I don't want you to have to wait for it. So I'm going to type that in here, 1 plus 4 cosine theta. And we need to be in polar mode. It's still going. I mean, it is really stuck there. So polar mode, table set. Zero, and counting by pi over 12. Okay, window from 0 to 2 pi, and also counting by pi over 12. Oh, it stopped finally at 14, which is absolutely crazy. All right, I finally got it to fix there. I just paused it and waited it out so that way you guys could see it. So theta is 0, r is 5, so that goes all the way over right to here. So that's our first part. Then at pi over 12, we have 4.8, so just barely below. Next value is 4.4 and then 3.8. So 4.4, about right here, and then 3.8, about right there. Then we've got 3 and 2.03, and then 1. So essentially 3, 2, 1, very close to those. So 3, 2, 3, 2, 1, down here. And then we've got negative values, which remember just means we're going to go in the opposite direction. So I'm going to scroll all the way down here so we can see these values. So that means when my theta is pi over 2, I'm going to travel in the negative direction 0.3, which of course is almost nothing. So it's still kind of on that dot there. And then we have negative 1 at this value. So that means that we go, remember, directly across. So negative 1 would be right here. And then negative 1.8 happens when our theta is over here. So again, directly across, negative 1.8 would be right here. Then we've got negative 2.5, negative 2.8, and negative 3. So negative 2.5, 1, 2.5 would be right about here. The negative 2.8, because again, it's all going from this direction. And then we have negative 3. At pi, we get over to negative 3, which would bring us here. And you can see that we're starting to make, that middle loop is what's happening there. So we started over here, and we're looping around. So we're to here right now. Then let's see, go past the pi, and we've got negative 2.8. So past the pi, negative 2.8. It's hard because it keeps going away. And then negative 2.4, negative 1.8, negative 1. So 2.4, 1.8, negative 1. So looping back around. And then we get back to about 0. So at 3 pi over 2 then, so let me loop this all the way around. So that comes back to 0. And then at 3 pi over 2, which is the 4.71 value, we're back at positive values, which means we go to 1, which is right here. And then we continue in that direction. So 2.03, 3, going all the way out. So 2.03, and then 3. I can't get it to plot. There's 2.03. There's 3. Then 3.8, 4.46. So 3.8, 4.46, 4.8, and then back to 5, which completes the outer part. And so then we have a very lovely graph, and we are done. Sorry about the difficulties in there. That took a lot longer than it should have with having to flip back and forth. Hopefully that makes sense for how we're going to graph these. On the worksheet that you have for homework, I not only have some polar graphs on there, but I also have some review of what we did in 6.3 to help you practice with those.